Yes, am I audible? I hope the screen is visible, right?
Yes, sir.
Okay. So let's wait for 2 to 3 minutes before some people join, and then we can start. Meanwhile, if some doubts, you can ask. Any doubts of the 12 weeks? Any doubts from the assignments or from the problem solved previously? You can just start asking. Because today is meant to be the final live interactive session. We have kept a review slot for 1 hour. 1 hour will solve the problem today, and then after that 1 hour we'll just revise some important stuffs. But you should, if you have some doubts, which I already asked you previously in the last week or previous session, you can ask your doubts from any of the 12 modules today, and they get them clarified. If you have some doubts in understanding different concepts, want me to revisit some type of problems and solve 1-2 examples maybe, so I can do it for you. Okay, any of the concepts from 12 weeks, you can ask doubts. If you don't have doubts, then I will ask questions to you. Okay. No doubts. You should have doubts. Ask anything of the 12 weeks. Yes, no one is telling anything, so I will ask. Okay. Can anyone tell me definition of half wave symmetry? Yes. When is a waveform half wave symmetry? So in a half of the time period, if you shift it by half of the time period, the signal will be negative of that it was in the original signal. If you have the original signal, you just shift it by t by 2 and see if it is negative or not. So I am drawing two waveforms for you. One is this waveform. So this is x1 of t and versus t is x2 of t and with respect to t, and if we have x3 of t, that may also work. X4 of t, we can also have another signal like this. So tell me what you can say about x1, x2, x3 and x4. Tell me.
Sir, x1 is a square wave.
Yes. So what can you comment about its properties? If I can ask you, if I ask you by just seeing the waveform, what can you comprehend about its properties? Because we are in the power quality course, so we should be thorough with the harmonic analysis. If I ask you about some harmonics, what are the harmonics present, you can have some conclusion by seeing the waveforms. So tell me one by one, take one signal, see it, analyze it, and tell me what you can apprehend about its properties or presence of harmonics by some rules which I have already discussed. Yes. So x1, if you take x1, it is periodic or not?
It's a periodic.
x2 is also periodic. x3 is also periodic. x4 is periodic or not? It is a constant signal.
Constant.
We can say it is periodic with time equal, that is your step time or cycle, one cycle, what is t, that tends to infinity, right?
Yeah.
So we can tell like that. So it can be told as aperiodic, right? Because we are talking about finite time period signals. So what can you tell about the presence of harmonics in these above three? Because aperiodic signal don't have concept of harmonics, right? Only in terms of periodic signal you can break it into Fourier and then compare the harmonics. So what can you tell about these three signals? Which one is odd, which one is even, or which one is half wave symmetric? Remember,
We have only odd harmonics.
so x1 is half wave symmetric, first observation, as well as it is odd. That's why the even harmonics are absent.
Yes.
Similarly, x2 is half wave symmetric. Is it odd? Think.
X2 is even.
No, I am just asking, what can you tell? Is it half wave symmetry? Is it odd? Is it even or what?
Even, even.
So what can you comprehend about the presence of harmonics? Just think about it. Is it half-wave symmetric?
Yes, sir. It's half-wave symmetric.
How can you tell that?
Sir,
It is 0. It is t by 2. It is minus t by 2. And for example, this is again 1 t by 2 cycle. So t, and then for t it continues with 2t, right? This is t, the width. And t by 2 is the, for example, you take t by 2 as the gap. So t is the width of that square pulse, t by 2 on this side, t by 2 on that side, and then you have t by 2 gap, and then you have again a t slot, t signal. Okay. So just can you just tell me whether this signal is odd, even, or what? What is the time period of this signal?
Time period is 2T only, no, sir?
Yes. So if you know that, then this is how much time interval you should check from this to this next cycle. Okay.
Yes.
So if you take, then you will get t, and your this is t, and this is t by 2 and t by 2. Okay.
Yes.
So what is the time period? If this is t, then this is also t, right? So this is 2t. Then this is t by 2 and this is t by 2 again. So 3t is the time period, right? Not 2t.
Okay. Yes.
Because where is the next same thing coming?
Yes. 3T.
You have to just consider that. So t is the width of two such there, positive and negative. So t plus then t by 2 and t by 2. Two gaps are there. So similarly, this also 3t. Likewise. So this signal is odd signal or even signal?
Even signal.
So is it half-wave symmetric or not?
Yes.
Just shift that signal by half the time period. What is the time period? 3t by 2, right? So 3t is the time period. So shift the signal by 3t by 2. That is here. Whatever was here will come after 3 by 2, 3t by 2. So one half cycle and then one full cycle, right?
Yes.
So just check whether it is coming negative of that which was in x of t. For example, you put t equal to 0, okay? So what you should get? X of 3t by 2, which is the actual 3t is the time period. So half of that time period should be equal to minus of x of 0. Now what is x of 0? X of 0 was t. So x of 3t by 2 of that shifted signal should have been minus of that. So is it like that?
Yes.
No, right? How? Yes. Where is 3t by 2? X of 3t by 2, where it is? Yes, right? Please check. I want to hear from you. Is it yes or no?
Yes. Yes, sir.
Yes, right? So x of 3t, similarly you can do for other points. For example, let us take x of t by 2. That t by 2, okay? So t by 2 plus 3t by 2, half of time period, should be equal to minus of x of t by 2. So what is it? X of 2t should be equal to minus of x of t by 2. Is it true or not? Again true, right?
Yes.
So it is can be a half wave symmetric. X of 2 is half wave symmetric, okay. Is it odd or even?
So even.
Correct. But does it contain odd harmonics or even harmonics? So odd signal or even signal?
Signal is even signal.
Yes, yes. So signal is even. And signal is also Symmetry.
Half wave symmetry.
So what kind of harmonics it contains, if I ask you? Can it contain even harmonics? It is a even signal. Can it contain even harmonics? Please be careful, okay? Signal is even. Can it contain even harmonics? Being a half wave symmetric signal? No, right?
No.
Half wave symmetric signals don't contain any even order harmonics. Please be sure about that. Can anyone comment more about this signal? X2. Can anyone comment more about this signal? X2. Some additional information. Yes. Anything you recall? All these points have already been discussed in week 1 and 2, but still I am discussing again. So note it down. Okay, these points are important. To analyze the kind of waveforms, their nature, whether they are odd signal or even signal or half wave symmetric, and from there you can conclude about the presence of different kind of harmonic orders, right? So now the question is, we determined it is a half wave symmetric and obviously even signal, not odd. So also knowing that it is a half wave symmetric, we determined that it cannot contain even order harmonics. But something more? So it does not contain third order harmonics, okay? Since it is quasi. Whenever you see symmetrical quasi waveforms, which are half wave symmetric, then they don't contain third order harmonics. Like you see in three-phase diode rectifier waveform, input side waveform. The sound is coming. Okay, please mute. So what I'm telling is, as you see in the input side current waveform of the diode bridge rectifier fed with a constant current type load, and if you see the input side AC current, it will be quasi. Since I told you also this point yesterday that in three-phase three-wire system, there cannot be any third harmonics due to the violation of Kirchhoff's current rule. So third harmonics cannot exist in the three-phase three-wire system. So it cannot flow in the lines. That's why the current is quasi nature. If you just go back and see the waveform of the input AC current of the diode bridge rectifier fed with a constant current load, you will see quasi current nature. That quasi current nature, if you break it down, you will not find any third harmonics, you will not find any even harmonics also. Other higher order harmonics, odd harmonics, you will find because the waveform is distorted, square waveform. Okay, like that can be a point. Okay, so that is good point and that should be remembered. And another is X3. Anyone? Any comments about X3? Odd or even? It is easy, right? X3, just tell in one line. What is it? Yes, please. Someone please respond because this session is meant to be interactive and you are not answering. So there is no meaning of just going on. Yes.
Sir, as you go by the Fourier series, A0 and AN is equal to 0.
No, then what is its significance physically? Is it a odd signal or even signal? First, First, you tell me it is a odd signal or even signal. First step. Signal. Okay. Odd signal or even signal. No. What is the what is the definition of odd signal? If you place a mirror on the mirror, then the one part should be the negate of other y-axis. I am telling. That is the definition of odd signal. Okay. Yes. Or in other terms, x of t plus t should be equal to minus xt for odd signals. Going mathematically. So it is a deflection is negate of that. So it is not so. So it is a even signal. Is it half wave symmetric? Just put x of t plus t by 2 is minus of xt. Is it true? No, right? Please tell. Nobody is answering.
Yes, sir. It is not half-wave symmetry.
Not
It is even
half-wave symmetry. Correct.
it is even signal,
Correct.
but not
It is
half-wave
not
symmetry.
half-wave. Correct. Absolutely correct. So it is signal, but not half-wave symmetry, as well as not a odd signal also.
Yes, sir.
Not odd signal also. So it is a even, right? Even signal, simple. So can I ask you another question? If will it contain any odd order harmonics? Will it contain odd harmonics? Hello.
In the even signal, sir, how we can verify odd harmonics present or not?
No, you determined it is even signal, right? I am
Yes, sir.
asking you about the harmonics. Don't confuse even signal with harmonics. Signal is even, agreed. After that, I am
Yeah.
just asking you, by seeing the signal, can you tell that whether it contains odd order harmonics or even order harmonics? Or both?
Harmonics.
Harmonics, I am telling, not the signal. Okay,
Yes,
signal
sir.
is even, agreed. But what now I shifted, so I will write even signal. Okay, don't confuse. Now, next question, we move to the harmonic analysis. And okay, we have a square kind of thing and then 0. So that is the period of that waveform, square and then 0. Now, if I tell you that it is okay, it is even signal, okay. Because if I move it by t, and then I get same value, okay. Because the time period this you consider as t, and if I move from here, okay, by, for example, this is also t. If I move by 2t, I will get the same value, so it is even signal. It is symmetric. So even signal is confirmed, but I am asking you whether it will contain odd harmonics or even harmonics. First tell me what is the value of A0. A0 will be 0 or not? DC value in a Fourier. Nobody is answering. Please try. A0 means the DC value. The DC value of such kind of signal is 0 or not? Please try. If you try, you will get everything. Okay.
DC is not 0. DC is
Correct.
0 here.
Correct. No, DC is not 0. DC means average value. If you average over this kind of waveform, please think
Yes.
analytically, okay, with logic. If you average this waveform, how it is 0? There is no negative lobe, right? So if you
Yes,
average
sir.
this pulse 1 by t integral
Yeah.
xt dt, that average will not be 0. So A0 is not 0, okay?
Yes.
So it has some DC value. If I ask you, it has some DC value, okay? One part
Yes.
you answered correctly. Next step, we move to the Fourier analysis, second part. A0 is 2 by t integral t by 2 xt dt and b into sine of t. And then B0 is into cos of t. So as I told you that can you tell what for even signal A0, AN and BN, those two terms are there, na? AN and BN of Fourier. N comes with cos and BN comes with sine, right? And AN is the strength of nth harmonics, right? Odd as well as even. So Bn is with sign. So what can you comment about An and Bn? What is the product of two even signals? Recall week 2 and week 1. Product of two even signals is? Hello? How you determine An? An is nothing but 2 by t integral t xt dt into cos t, cos n omega t, right? So if you product xt with cos, if xt is even, then even into cos is also even. So even into even becomes even signal. Odd into even becomes odd signal. Odd into odd. But odd into odd, also even signal. Odd into even, odd. Even into even is n. So now if you multiply, if you try to find the value of an, which is the nothing but the product of two even signals, then an is not 0, right? Because integral over a time period will not be 0. But what happens with bn? Getting my point, or you are not getting? Please let me know. Hello? Hello? Please respond.
Yes, sir. Yes.
So what I'm telling, an value and bn value. An value is nothing but product of two even signals. If you integrate an even signal over a time period, is its value 0 or not? Even signal means t by 2 and t by 2 same. T by 2, and if you shift that by t by 2 and then t by 2 is the time period, half of the time period, and you integrate over a complete cycle of that even signal, will you get 0 or not? No, right? Because even signal looks how? Even signal looks like this. So this is t by 2 and this is minus t by 2. If you integrate, you will not get 0. So an is not equal to 0, but bn is a odd signal because you are multiplying an even signal, which is our signal, x of 3 is an even signal multiplied with sign. It will give you even signal multiplied by a sign, which is an odd signal, is giving you even into odd is odd.
Odd.
Plus into minus is minus, like that. So odd signal, if you integrate over a time period, then it will give you 0. You take any odd signal and see, you integrate over a time periodic odd signal. If you integrate over a time period, then it will be 0. So bn is 0. But bn becoming 0, does it signify anything about the harmonics? An is not 0. So if an is not 0, then there will be a1, a2, a3, a4, all. So both even and odd order harmonics will exist. It is not like that bn is 0 means even or odd will not be there. Okay. So both harmonics will exist. Okay, for this kind of signal. That was the essence of a basic just concept that in the basic Fourier analysis you need to understand. Okay, we'll cover more, but let us move on the numericals on microgrids. Okay. So can you see the question? Yesterday I have given you this question. Read the question and we'll solve it. Okay, it is an interesting question. It is telling a AC microgrid with a 40 kilowatt rated wind energy conversion system. We have the generator, that is squirrel cage induction generator, and this is a wind turbine. The 50 kilowatt is the rating, at 12 meters per second wind speed. And solar is there, 50 kilowatt, 1000 watts per meter. This is also the rating of the solar photovoltaic array. So you have two sources, solar and which is feeding power to the three-phase grid. And the microgrid is connected to 60 watt local load also. So you can draw like this. You have the wind energy conversion system at the AC side, and you have the solar plus inverter. Solar plus inverter is AC or DC? Solar is DC. Solar plus inverter is AC or DC? It is AC only, right?
Yes.
And then you have the grid, and you have the load. The point at which all are connected is known as the point of common coupling. So this term you might be quite acquainted with. So one is generating some power PW, one is generating some power PPV. These are throwing power at PG, and load is taking its own power PL. We talk in terms of power to make everything simple. Okay, for three-phase analysis, we do using power approach, right? And it is asking that if the renewable energy sources, by renewable energy sources we mean the wind energy conversion system and solar energy conversion system. So renewable energy source, both of these. So these are operating at their rated condition given. So what is the rating? This is 40 kilowatt at 12 meter per second, and this is what? 50 kilowatt. Okay. Solar. They can only give power. That I discussed yesterday. They can only supply power, not take power. Both the wind and solar can only give power. And they're meant to be doing so. They're meant to be generating power from the renewable energy. Okay, wind or solar. So now the microgrid operator, your local load operating power factor is given 0.8. Okay, this is 0.8 power factor. Okay. Now then, if the renewable energy sources are operated at their rated condition that is given to you, then calculate the RMS value of the injected grid current in amperes. So the grid current RMS actually value is being asked. Okay. And also one information is given to you that the microgrid operates at unity power factor. This total system, if you call it a microgrid, then this microgrid is operating at unity power factor. Can anyone tell me what does the microgrid operating power factor actually signify? This line, microgrid operates at unity power factor, but just now you saw it is 0.8 lagging power factor of the load. So whose power factor are we talking about here? Whose power factor is being talked about while telling microgrid operates at unity power factor? Whose power factor? Which side? Yes, please. Load side.
Sir, customer side or load side power factor?
Load side power factor is 0.8. But here it is given microgrid operates at unity power factor. So who is operating at unity power factor? And whose power factor is actually referred to by the microgrid power factor? Or the
Sir,
system
AC
power
side.
factor? Yes,
AC
it is the grid.
grid.
Because I told you the person who is most bothered about power factor is who? Is the one who is actually
Supply
giving
source.
the power. Supply. The supply, yes. The source. Because they have to pay for the penalty. For your poor power factor of the load, they are the one who are penalized because you are not paying for that power. Because I told you that for non-unity power factor at the grid side, the current RMS value is more for the same amount of active power to be transferred, and for the amount of active power to be transferred being same, if you push more RMS current, line losses IRMS line will more. So that will cause losses, but you are not paying for it because how I told you the reactive power looks like what? It comes and then goes in one cycle, plus and then minus. So you are not absorbing it. Your meter is not recording it as being power absorbed. But that RMS current is flowing in the line and the line has some resistance. So copper losses happen. So those losses you are not paying for, but they are being penalized because they are being dissipated in the line. So it is more important that you operate the line at unity power factor, which is the best possible power factor you can get, such that your line losses are minimized. Do you get my point?
Yes.
So whenever someone tells you system power factor or microgrid operates at unity power factor, it is implied that it is the power factor of the grid. UPF. Okay. So now you are also told that the converters don't provide any reactive power compensation. Okay. So can you calculate the same for half the? Okay. So it is first asking you to calculate for rated, and then it is asking you to calculate for half the rated of the wind speed, and then some more questions are being framed. So first question is what? That they are asking you to calculate for half the rated, right? So can you do so? What is the starting point? If I ask you what is the, then how can you determine actually the grid current? For that you need to calculate the net power pushed to the grid, agreed or not? PG. If you know PG, you can calculate that, right? At different conditions. So how to determine PG? Nobody is answering. Please think analytically and try to answer, okay? And do with me.
So both power microgrid and solar photovoltaic we can add.
Yes. So yes, correct. So if I calculate first, I am calculating for rated, okay?
Yes.
Part 1. So what is the at rated PG rated? What is the rated power pushed to the grid? Net rated power pushed to the grid. PG. How to calculate? Tell me. Wind is generating how much? I wrote everything in the diagram.
40.
No, wrote everything in the diagram. 40, yes. 40 kilowatt, okay. This is P wind. And your solar is generating 50 kilowatt. This is PPV. Then who is taking someone is there sitting there at the PCC who is also absorbing some power. So who is that? The load, local loads, we tell them. So what is the rating of the local load? 60 kilowatt given at rated. Now I tell you what is the net power pushed to the grid. You wrote as 30 kilowatt at rated. Okay.
Sir,
Now
here
can you tell me?
one doubt, sir. Here rated power load is having 0.8 power factor, no?
Correct. But what is the power factor significance? When I give you kVA, then you multiply it with power factor to get kilowatt. But I gave you kilowatt only.
Okay, then. Okay.
Yes. I already gave you kilowatt only. That power factor I gave you agreed for some other reasons, but I told you indirectly the power factor only and the active power consumed by the load. So power factor can be used to determine kVA rating of the load and the reactive power consumed by the load. But your active power information is already available with you. If someone gave you the kVA rating of the load and the power factor, then you multiply both and get the kilowatt. Okay, because your power factor into kVA is kilowatt. Okay, the reactive power. The ratio of kilowatt and kVA is power factor. Accordingly, whatever you know, other parameter you can calculate from the two. So I directly gave you active. Please check it. If it's kilowatt, then no need to do again with the power factor. But if it is not so, then you have to calculate the kilowatt rating. I hope screen is lagging again. So I will just stop and then reshare. Yes. Kindly check. Screen visible?
Yes.
No, slides are not visible.
So I will just give me one. Visible now?
No,
No.
sir.
Yes, visible, visible.
Yes. Yes.
But I cannot see the slides. Now visible, right? Just one of you confirm.
So slide is not
No,
visible.
sir. Not visible, sir. Yes, sir. Slide has come.
Yes.
There must be some technical issues because I'm doing the same thing, but it is not visible here. Till now, I think it is not visible, right?
No,
No,
sir.
it is not visible.
Just give me 1 minute, okay? I will disconnect everything and reconnect. Give me 1 minute. Now I hope it is visible.
Yes, sir.
Okay. So what I was telling, I was calculating the net power injected to the grid at the rated condition, and I got 30 kilowatt. Up to this, everyone is clear or not?
Yes, sir.
So now, what is the RMS current? Can you directly calculate RMS current? For calculating RMS current, you need 3 things. What are that?
Voltage, power factor,
Yes. Voltage of what? Grid.
grid.
And you want to find IG of grid. This you want to find. This you have. This also you have. Another thing you need
Power factor.
of grid
Yes, sir.
that you still don't have, but that is hidden.
No.
That information is hidden somewhere. So can you decode it? Just
Unity
read the
power
problem.
factor.
Yes.
Unity power factor grid is operating.
Yes. So what is the reactive power delivered by the grid?
Power zero. Reactive power.
0.
Yes. Reactive power is 0, right?
Yes, sir.
So now can you calculate the reactive demand of the load? What is the reactive demand of the load?
It should be, sir, 36 kilowatt.
Hey, reactive demand is not in kilowatt. It is in kVAR.
36 kVAR.
Correct. QL is 36 kVAR. Okay. Agreed or not? So who is feeding the reactive power to the load? Please be clear about your concepts. Okay. Here you are written that it does not provide reactive power compensation. Okay. So who is providing reactive power then to the load? Because the converter is not, this converter is not providing any reactive power support to the load. So who is providing the reactive power to the load? This is not also providing any reactive power. Can grid operate at unity power factor? Because unity power factor of the microgrid is given. The microgrid is operating at unity power factor. Then two things are there. Either the wind is operating at unity power factor or the grid is operating at unity power factor, because both are AC sources. But it is also given that the microgrid, by microgrid I mean the wind energy conversion system and the solar conversion system, this part. This is connected to the grid. So the microgrid is operating at unity power factor means that the wind energy conversion system AC supply side, which is also a part of the tied to the grid, is at UPF. And because it is not providing any reactive power compensation, but the grid cannot be at UPF here. Okay. This wind side AC side supply can be at unity power factor because it is not providing any reactive power compensation. But the part of the grid that is all on the other half of the PCC cannot operate in this case at unity power factor, since the microgrid is not pushing any reactive support to feed the reactive demand of the load. Microgrid is also AC, okay? So microgrid side AC supply power factor, that is given to be unity. Please understand that grid power factor is not given to be unity. It is tied to the grid. Microgrid side AC side power factor, which is also part of the grid, is unity. But the grid power factor is non-unity. So grid will feed the reactive power to the load. So this is 36 kVAR. So QG is what? 36 kVAR. Can you find SG? Root over PG square plus QG square. Find SG. Tell me the value. Because once you find SG is what? Root 3 times VGLL line to line into IG RMS. Then from that you can find IG RMS. So determine SG first and then calculate IG RMS. Tell me the answer directly, okay?
36.
No, 36 is QG. You calculate
Yes,
SG.
36 you took from where?
36 where you are getting? 36 is the... Did you calculate correctly? Where from you calculated 36 QL? 60 kilowatt is the power PL. So how you calculated QL? QL will not be 36, okay? Calculated wrong. Whoever said 36, how we calculated? Can anyone tell me? What is the reactive power demanded by the load? If you draw the power triangle, if this is P, this is Q, and this is the angle, then this is cos inverse 0.8, which is 30 degree. So what is
48
what
sir, SG.
P by Q is 10 of 36. So what is Q? P by 1036, right? So what is P by 1036? Do and tell. P is 60. Okay.
Sir, how much SG is coming? 48.
Which one? Yes, what is the answer coming? Hey, I wrote P there this side. This side will be P, right? You are not telling me anything. Power triangle also you don't tell me the correct thing. This is the power triangle. Power triangle base is the P and then Q is the arm. Okay. So tell me correctly. So this is P into 1036. Okay. You're not telling me anything. P into 1036. Assume I don't know anything and then try to apply the problem. Okay. Then only you will learn. P into 1036. Okay. So what is the value of Q? No, none of you are calculating with me, I think. What is Q value? P into 1036, you do and tell me the answer.
Sir, what is SG value?
No, you calculate SG value.
SG sir coming 48, 48.
Why going to SG? First calculate QL. Whatever I am telling you, first do that. QL, what is the value? Because SG will come after that step. Okay, don't jump the step.
kVAR.
44.98 QL.
Around 44 kVAR. Okay. Now
Okay.
this load reactive power demand will be supplied by the grid because the microgrid is not providing any reactive power compensation as given in the problem, this line. So all the reactive power demanded by the load will be given by the grid, for which QL equal to QG, because grid will feed the reactive power demand to the load. Now once you know QG, you can calculate now SG. QG is what? 44. PG is what? PG is what? 30. So calculate now SG. 30 square plus 44 square whole root over. Tell me answer of SG. And then IG also you tell me the answer. Hmm?
53.25.
Around 54. Okay, 54. What will the unit of SG? Apparent power unit is what? Kilovolt
kVA.
kVA. Yes. 54 kVA. Now you know PG and QG both, and then you calculated SG. SG came out to be 54, around 54 kVA. From that information, you let me know the value of IG. Tell me IG value using this relation. Simple, right? Please apply fast because we have 2 more problems of multiples to be covered. Could we jump in to solve your doubts? Do it fast.
ST also is not 54, sir. ST also is coming 74.40.
30 square plus 44 square. What is it coming? Let me see. Then whole root over. Don't forget whole root over. Okay. Yes, it is around 53.25. Around 54 you assume. Approx, okay? In the exam, do correctly, do full, but I am writing approx. So now you calculate IG value, IG RMS, okay? Line current of the grid RMS. Yes, please try to solve, okay?
Sir, Q value we can't calculate directly with sign, means 0.8 is given. So
Yes. See, whatever trigonometry you apply, because once
60
you know
sign cos is 0.8.
Why you are not understanding the thing. 60 sine cos inverse 0.8 will work only if 60 is kilovolt ampere. That is this one. See the triangle. See the trigonometry. See in the diagram. What is this? What is this? This is X. And this is kilovolt ampere, apparent power. Okay. What you are given here? Yes. You are not given here apparent power. You are given this base P.
Yes, sir. Yes,
So
yes.
in order to get Q, that one will not work. So see the power triangle always. Apparent power, if it is given, then that cos sine of cos inverse 0.8 would have worked. So best point is whatever is given, you see in the triangle.
Yes, sir. Yes, sir.
And try to calculate the angle, and from that angle you apply trigonometry and try to get Q value. Because once you get Q value, you can get S value. Once you get S value, calculating I will be easy. Because for calculating I, you need three things: power, voltage, and cos phi, power factor. So if you don't need cos phi, you need to calculate S, because then only you need S. Okay. So we calculated S. You can also go with power, because now we know the cos phi. Cos phi G. That is phi G means the power factor angle of the grid. So what is the power factor angle of the grid? Because you already know. Can anyone tell me power factor angle of the grid also? Let us calculate phi G also. Because now we know QG and PG. From there, this angle I need, phi G. Which angle you understood? This angle of the triangle. That is the power factor angle, theta. Power factor angle you calculate for me. Both you calculate, IG and phi G. Tell me. So phi G is what? Is an angle. So how to find that angle? You have the arms of the triangle P and Q. From that only you can just tan inverse P by Q. Sorry, tan inverse Q by P. What is tan inverse Q by P? Phi only. Someone can apply cos also. For that you need base and hypotenuse. So tell me what is phi G value in degrees and IG value also. These two things you need to tell. Do with me, okay? Step by step. Just apply the relation and tell me the answer. Anyone doing or no one is doing? Please try, okay? Such problems can come, okay? Important problems, so you just solve them.
Phi is 36.86.
Phi G, right?
Yeah.
And next one you calculate IG.
IG came around 75.12.
Yes,
Okay.
sir. IG 75.
Okay. So what you told, phi G value, what you told?
36.8.
How you got 36.8?
Cos inverse 0.8.
55.
No. Cos inverse 0.8 is different. Please understand. You are doing a conceptual error. Cos inverse 0.8, why? 0.8 is whose power factor? Grid or load? Please understand.
So it is
Please tell me.
55.7.
No. Just hold on. Whoever said cos inverse 0.8, please, you can be interactive. and tell me 0.8 is whose power factor, grid or load? Hello?
Loads.
Load. But we are taking the information that since the microgrid is not providing any reactive power support, the load reactive power demand is being made by the grid. To find the load reactive power, we use the cos inverse 0.8 and all those things. The load power factor information. But grid power factor is not 0.8. Okay. Is that clear to you? If grid power factor is
Yes,
0.8,
sir,
neither is it unit.
network is lagging
So
sometimes.
how to hold on? So hold on, please understand. How then can you find grid power factor? You know, for finding power factor or power factor angle, two information you need of the triangle. Which triangle? The grid triangle, the grid power triangle. Now don't use the load power triangle. What is this? Load power triangle. So when to use load power triangle? When you want to find the information about the power of the loads or the angle of the loads. Now we want the information about the grid, 5G. So 5G is the grid information. So what to use? PG, QG, and then 5G. So grid power triangle I want to make. For that I need two information. What is PG? 30. What is QG? 44. Then can you find the angle of the grid power factor angle? This triangle you see. The star triangle. Star mark triangle in the screen. Now can you tell me 5G value? QG is 44. The triangle height. The triangle base is 30. What is the power factor angle? That means the active and reactive power are given of the grid. Where from we obtain the reactive power of the grid? From the load information. From the load power triangle. We determine.
Then phi is 55.7.
Correct. So whenever I ask you of the grid information, draw the grid power triangle. Okay. Clear? Or any doubt? You ask me if you have some doubt. Because these concepts are very important. Otherwise, I can just jump like mechanically and you will not get anything. Right? So basic thing is
Sir,
to just
in
make
the
you
question,
react the concept, right? Please ask. Please ask.
sir, in the question, it is also saying microgrid operates at unity power factor. Then
That's what don't be confused. Okay, that's what the next
that
part of
is
the
not
question
grid
comes.
power factors.
Yes, that's why I am given the next part. Just read the next part of the question. Up to what part we solve? I will mark with blue color. I will just mark with blue color. I have solved till this. Okay. Rated, half the rated you just calculate. One cube information. Okay. Cube information, and for PW will change. Okay. P wind will change as per cubic relation, and all the same analysis will be there. But the power factor will change obviously of the grid due to different power injection. Okay. So half the rated wind speed, this term will change. So I explained also the last day also, so that you can calculate. Sir, now you tell me, microgrid is operating at unity power factor. By that, who is actually operating at unity power factor? Grid or who? Again, I am asking, which is the second part of this question. Mark with blue color. Because this line created the whole problem. That it provides no reactive power compensation. So it is talking about the microgrid as a system, as a AC system, is not providing any reactive power compensation to the load, because load needs some reactive power. But the microgrid as a system, as a AC system, will not push or provide any reactive power compensation. So we will compensate, grid will compensate. So then who is operating at unity power factor? Because neither the load nor the grid is at unity power factor. That you also learned. Because cos of 50 degree, which is 5G, is 0.5. So grid is operating at 0.6. Which is a hypothetical situation because grid power factor is always close to unity. But for this problem, taking into consideration the load and the grid power levels, the grid power factor is not that good. But then who is actually operating at unity power factor? Tell me. This time
Means
point
only converter remains.
means that the microgrid
It is just
AC point, right? Microgrid AC side. Those AC terminals, if you combine in parallel and then take it as a node and a system, then that AC terminal voltage and current are at UPF, because that is not providing any reactive power compensation. So this terminal is at UPF, this juncture point, okay? But this point is of the grid is not at UPF because it is providing reactive power to the load. It is supplying QL. So it is the microgrid system, AC system, which is operating at unity power factor, the converter terminals, okay?
So what will be the value of grid current IGRMS?
IGRMS you just see from this relation, SGU plugin 54 divided by √3 times VG line to line. So 54 divide √3 into your voltage line to line value. Voltage line to line value is 415. So you get how much? Into 1000, right? Because it is in kilo. So around 75. Okay? Around 75. And for half the rated also you calculate for satisfaction. What will change? You just change this one. Okay. So what is it? 12 cube is the rated, and now the wind speed is half. So 6. So 6 cube by 12 cube. By that factor only the wind power will change. Because with the wind speed,
So
it is
VGLL, what is the value?
VGLL is this one. This one. Given 415.
Okay, sir.
It is given now that to a 3-phase 415 50 hertz grid. Lead this line. So now you just for the second part, 6 cube by 12 cube. Okay, that factor it will change. So what is 40 into 6 cube by 12 cube? Calculate. 5, right? So wind speed is now 5 kilowatt. Sorry, wind power generated is now 5 kilowatt for half the rated speed. Okay, because it is related cubically. Okay. Other things same. So now wind is pushing 5. Solar is
What is the value
50.
of IG, sir? IG, sir?
75 amps.
75.12 amps.
Yes. Now you see, for the half the rated wind speed, the wind power decreased to 5. The wind is pushing 5, solar is pushing 50. Then can you tell me then what is the power injected to the grid? It is minus 5 watts, right? Means grid is supplying active power to the load. So accordingly, you know PG and QG will be same as QL till then. So QL is 44, QG is also 44, PG will be now 5. Take the magnitude, and SG you calculate accordingly. Okay. 5 square plus 44 square. Okay. 5 is the active and of the grid in half the rated condition, and 44 same as previous. 44 is the reactive because load reactive power did not change. So around 44 will be SG at half the rated. And for that 44, calculate the grid current. Grid power factor also will change. So calculate 5G and IG at half the rated condition and tell me the answer. Yes, please. Everyone understood the question? Half the rated, you calculate IG and 5G value, power factor value of the grid, and then IG value. Because I already gave you the values, right? 5 kilowatt is the power and active power, and then 44 is the reactive. So from there you got your SG to be around 44 only, and remaining things you calculate. 44.2 will be SG or 3, 44.3 kVA kilovolt ampere will be the SG value. From there you calculate and tell me phi G and IG. So now the active power is less and then reactive power is much higher, which is 44 divided by 5. So what is it? 1.
Sir, P is 3.75, sir. Active.
Who is 3.75?
P means, sir, due to change of speed, P will change, sir.
P changed, already changed. P is now 5. I told you to calculate phi G, power factor angle. What is power factor angle? Power factor angle you want.
3.5, sir.
How you calculated? 5 tan inverse. You see the grid power triangle,
Yeah.
okay? Grid power triangle gives you what information? 44 and 5, okay? So using this, if you calculate, then what are you getting? Cos of, first you tell me the angle. What is the angle?
Angle is
83.5, correct?
83.5. Yeah.
Correct, exact. 83.5 degrees. So you see that since the grid is completely providing the burden of the load reactive demand, its power factor is quite poor now, because the power is quite active power handled by the grid is now quite low, and then the reactive power is quite high. This is not a normal condition because we use the inverters to compensate for the load reactive demand to improve the grid power factor. But this problem is framed in such a way to show you that if we don't provide reactive power compensation using the converters of the renewable energy sources, then as your active power injection to the grid reduces, then power factor becomes very poor, which can be improved using reactive power compensation by taking advantage of the inverters of the renewable energy sources. So you see that due to the high variability of this renewable energy source, your grid power factor could have been quite varying, right? For which you have been penalized. But due to improved control and of the converters tied to the renewable energy sources, we achieve additional advantages out of them by using the inverters, so that the grid power factor is not decreased even during power variation of the renewable energy sources, since the reactive power of the load is provided by the converter. So phi G or QG is 0 only, because grid don't have to provide any reactive power in such conditions. So whatever be PG, power factor is close to unity if the load reactive power demand is provided by some other sources like the converter. In those conditions, whatever be the power level, active power injection level, your power factor does not care, because that is 0 degree, because QG is 0. Q of G means reactive power handled by the grid will be 0 in that condition, since someone else is there to meet the reactive power demand of the load. So since QG is 0, your phi, what will be phi? 0 only. Angle, power factor angle of the grid, 0 only, because QG is 0. See the power triangle. So once QG is 0, your power factor angle is 0 and your power factor is close to unity, which is economically also feasible now. That's why it is done. Reactive power compensation of the load side using the renewable side converters are very useful and economically advantageous for both the microgrid operator as well as the grid operator, because they help to save the money and also save the consumers from earning tariffs, because you as a consumer don't want to pay for something that you did not use. However, your load may be quite reactive, the nowadays loads. You don't want to pay extra for that, and that's why power factor correction is very important. That's why you have the inverters, solar inverters, and have some power factor correction features also embedded into them, so that you can compensate for the reactive demand locally, not from the grid. You don't need to demand any reactive power from the grid. You can compensate it locally using your rooftop solar inverters and compensate the load reactive demands, and don't need to be penalized for that, for whatever you did not consume. So that is why it is economically very much advantageous to use such converters and their control to meet for reactive power compensation. Okay. So last part is that operating power factor nature of the squirrel cage induction generator. So, do anyone know what is squirrel cage induction generator? Is it a doubly excited machine or a singly excited machine? By doubly excited, you mean two energizing coils are there or one energizing coil is there? By the principle of operation of the induction generator, how many energizing circuits or active circuits are there? Only the stator, right? For a squirrel cage machine, only the stator is excited. Or the prime mover, you give excitation mechanically and you take the electrically, you take the power from the stator. But electrically, you don't energize the rotor coils because rotors are shorted with damper bars. So only one. So it is a singly excited machine. So if you learn, if you see, then singly excited machines for their flux buildup and voltage buildup needs to be given some external. There needs to be some external arrangement for reactive power supply that for exciting the machine. You need to excite the machine and provide some external means to feed reactive power into the machine for voltage buildup. So you can learn this in machines also, that singly excited machines needs externally some reactive power arrangement. Some arrangement which will push reactive power to the machine. External some Q arrangements. Okay, I write Q arrangement. So for that, if some source or generator absorbs reactive power, I explained this concept to you also in the beginning. So can anyone tell me, if someone absorbs reactive power, what is the power factor? If a load is absorbing power, reactive power, then what is the power factor? What kind of load consume reactive power? Can anyone tell me?
Leading, sir.
A leading load deliver reactive power minus Q.
Delivers reactive power.
But
It's absorbing.
load,
Absorbing means lagging load, sir.
absorbing means lagging load, and that you denote by plus, because load are meant to be absorbing only. And since it
Yes.
aligns with convention, so absorbing lagging loads are considered to be plus Q. But
Yes,
in
sir.
the or the AC sources or the generators, if someone is delivering something, you take that to be positive. So if a generator is delivering lagging power factor reactive power, which is absorbed by the lagging power factor sources or loads, a generator is delivering reactive power and someone should absorb that reactive power. So who will absorb? Load will absorb. If load absorbs reactive power, it is taken to be positive. So generator delivering reactive power, lagging reactive power is taken as positive. But generator taking inside or absorbing reactive power is considered to be negative.
Yes, sir. Negative.
Absorbing reactive power, that is leading, and that is taken to be negative. So here your singly excited machine, which is now operated as a generator, is absorbing, or why it is absorbing? Because it has a magnetizing branch, and it needs to take the magnetizing current for excitation or flux buildup for voltage buildup. Okay, so it absorbs reactive power, so its operating power factor will be leading or lagging.
Absorbing, sir. Lagging.
But it is generator, right?
Generator. It should be leading, sir.
Yes. If a motor would have done, then you could have told. Since the load and it is absorbing, then it is positive. Positive means lagging. But since it is generator, it is absorbing also, so it is negative, and negative means leading for a generator. So what is it power factor? It is leading, right? Just the nature of power factor I thought discuss. Okay. So now some numericals on multipulse. So multipulse converters are nothing but you have seen diode bridge rectifiers, right? So if you see a normal diode bridge rectifier, then it is a 6-pulse configuration, okay? Because you have your DC after rectification in one full, that 3-phase diode bridge rectifier, if you see, is like this, and you feed some 3-phase sub excitation, okay? 3-phase, for example, okay? Then your DC side, you see voltages like this, right? 6. So it is normally 6 pulse. This VDs. But 1 second, I think my connection suddenly broke. Am I audible? Hello?
Yes, sir, audible.
Yes, the screen suddenly blew away. One second, I'm joining.
Screen is also visible, sir.
No, my computer screen I am telling, my desktop screen. Suddenly it went away. One second, na? So multipulse means multiple pulses in the DC. So why we want multipulse? Can anyone tell me? Just let us discuss till we just connect this. They are just rectification only, but using some improved techniques that I will just discuss. Okay.
To
Why we need
reduce
that?
ripples, sir.
And why is that important?
To reduce ripples.
I understood, but why is that important?
Otherwise, sir, losses will be there.
Yes.
Due to ripples, there will be losses.
Not totally losses. Somewhat it is correct, but more diseases. But it will lead to, if your ripple is reduced, it will reduce the what? You must have seen in the
Filter
lecture
requirements, sir.
Yes, filter requirement and also size of the input capacitor, DC capacitor of the inverter. That can be reduced because your ripples are reduced by some additional arrangement. And also you have more degree of freedom to control the DC link voltage. Because if those were not diodes, but IGBT based some converters, because we are talking about controlled converters, which are responsible for the rectification, then you had got more freedom or more degree of freedom or control over the DC link voltage regulation. As well as you could have gained more control over the input side current. Because in normal condition, if your diode bridge rectifier was there, it would have drawn non-linear currents, right? Agreed or not? If you just plug in some three-phase supply and have a diode bridge rectifier, three-phase 6-pulse, basic three-phase uncontrolled 6-pulse rectifier, basically uncontrolled rectifier, whatever you see in three-phase, to build this kind of DC voltages, the current taken by from the AC side of the supply is very distorted. Agreed or not? Quasi in nature. You saw if this is feeding some at the DC side some constant current loads, then the current taken from the AC side is purely, I can tell, quasi in nature, square wave and quasi square wave. Okay, I explained that to you. So to improve the current quality also, this multiple at the AC side, this AC side current quality also, if you use multiple such devices with some phase shift, you can tactfully cancel the harmonics. By Kirchhoff's current rule, some current harmonics may be rejected here, some current harmonics may be rejected here by providing some phase shift arrangement. And if you add those currents connected in parallel, then your current quality will be more improved and more close to sinusoidal. If you can provide two different kind of phase shifted excitation, phase shifted voltages to this kind of DBRs or this kind of pulsed, I can say converters, then your current quality at the AC side will be better. So both multi-pulse and multi-level converters are very useful at higher power levels or even in medium voltage levels to improve the current quality at both the load side, because load may be some motors or something. So those also need to be powered up at a better current quality as well as a better voltage quality. Now current you don't have in your hand, so you need to ensure the better voltage quality, and the supply current you need to ensure that it is not too much distorted. So current quality at the input side, that is the grid, is more useful, and you need to maintain some standards and some harmonics needs to be cancelled. So in order to gain better control over the DC link voltage, reduced filter requirements, reduced size of capacitor, as well as better current quality at the AC side, input side. So that for that, multi-pulse converters are very useful, but you need to give some phase shift like this. I will show you an arrangement like this. So why the transformer is used? Now clear? You must have seen this diagram quite a few times. Now I think you are clear why these transformers are used, right? Star delta transformers are there to provide different phase shifts. Because if you use star star, no phase shift is there. Because star star, face to face transformation happens. And for face to face transformation, you don't get any phase shift. To provide phase shift, the line voltage, because face to face transformation are happening, the line voltage is 30° phase shifted by star and delta. Okay. So to achieve the phase shift, star delta configuration connected with another transformation is useful. So the currents can be phase shifted and then again added, and then to benefit the current quality, right? So now you understood the purpose. To tackle such problems, it is very easy because the phase shift is being asked. So whatever be the pulse number, you divide it by 360, and that is the phase shift only. It is easy for you. Okay. So if someone asks you that for a multipulse converter, it may be 12 pulse. Okay. So 12 pulse, how does it look? 18 pulse and 24 pulse. What does they mean? How many devices are there? How many diodes or how many converters are there? For 6 pulse, how many converters are there? 1. Is 6 pulse, right? For 12 pulse, you need 2. For 24 pulse, you need, sorry, for 18 pulse, you need 3. And for 24 pulse, you need 4. Clear? Clear or not? Let me know.
Yes, sir.
So now,
Yes,
once
sir.
you have the 12 pulse, 2 such devices are required. As I also demonstrated you, na. This, what is this? This is the 12 pulse, right? Because 2 such are used with some phase shift. Phase shift is very important to cancel the harmonics and improve the current quality at the AC side. That's why you need transformers. Transformers are very useful here. Many kind of transformers are there, zigzag, T, and all those configurations exist only to give the phase shift and tactfully cancel the harmonics and add them back as per Kirchhoff's current rule by transformation laws and Kirchhoff's current rule. You can see the superposition theorem of this with this transformation, this with this, and then you see the reflection and add them back to cancel the harmonics and improve the current quality, because currents are otherwise very much distorted. Currents at these sides are also very much distorted, as you can understand. But after providing the phase shift and then adding them back, some harmonics are cancelled and current qualities are improved. So if you see, as you go on increasing the number of pulses, more degree of freedom you get and more harmonic cancellation possibilities exist. And with reduced number of pulses, or I can say devices, the freedom is not so much. So as you go ahead with higher number of pulses, obviously the number of devices increase, but you get more and more better current quality. So that is very important. So tell me, as I told you, to calculate the phase shift, it is very easy. So it is nothing but, because can anyone tell me that what is this width? It is 360 by 60 degree, right? Because one cycle, right? For a 6 pulse. Agreed? For one cycle for a 6 pulse device, you have 60 degree. So for 12 pulse, how many converters are required? I told you 2. So 60 by number of such 6 pulses, 6 pulse converters will give you the phase shift that you have to provide using some transformation arrangements to achieve that cancellation. Okay. So now you tell me, for 12 pulse, how many such converters you need? 2. So you need a 30 degree. So star delta will work here for 12 pulse. Phase shift for 12 pulse. So part A. Then part B, you tell me, for 18 pulse. What will be the answer? 60 by
20 degrees, sir.
20 degrees.
Or else this formula can also be written as 360 divided by 6 into number of pulses. Many ways you can write this formula, but because 6 means that in one device it is 6, so for number of pulses, or else you can just write it as 360 divided by number of pulses. That means 12 or 6. Agreed, right? Both all are same. 60 by number of 6 pulse converter required, or 360 by 6 into number of pulses. Sorry, this will not be number of pulses, but number of converters. Number of 6 pulse converters. So this is one type that you can use. Second, 360 by 6 into number of 6 pulse converters, same. Or else directly 360 by number of pulse. So more easy, because what is given? Number of pulses are given. 12 pulse, 18 pulse. So directly use 360 by number of pulse. So what next time I will do this? 18, okay. So what is this? 360 by 18 is what? 20 degree, right?
20.
So now tell me, PS for 24.
15, sir.
So what is it? 15, right? So you have to see transformers which can provide 15 and then fractional phase shifts. So for that, please note, if someone asks you, you must have seen also in the lecture that zigzag transformers are very useful, okay, for providing fractional phase shifts. You can use zigzag transformer, and there are some very good lectures on these multipulse and multi-level converters, or also you can see some lectures on three-phase AC transformers, right? Transformers, if you want to study, or if you are more interested in those connections, you can use some very good lectures on NPTEL for such AC transformer connection. Zigzag transformer, T, and many types of transformer connections exist for providing fractional phase shifts. So this is very easy, okay, and because not more than that we'll ask, because it will divert the topic, right? So you calculate for another this problem you take, just to get your concepts clear. Do you see the problem? Okay, first read the problem. This is another problem. So now this is a 12 pulse diode rectifier and feeding a DC load of 180 volts. So DC voltage is given to you, right? This is the DC link voltage, 180 volt. Let me just write VDC as 180 volts. And then what is it given? The required AC line voltage RMS at the rectifier input terminal. So what is it telling? Rectifier input terminal, whatever AC right voltage you require. So this voltage it is asking, okay. Rectifier input AC voltage. So you know three-phase diode rectifier, what is the conversion? Then 3√3 Vm by pi. Before I told you 3√3 Vm by pi. This is VDC. But what is VDC here? It is VDC by 2. What is VDC by 2? It is 90, right? DC side voltage. And to find, this is the phase peak AC voltage. But you need line peak, right? Sorry, you need line RMS. RMS, right? RMS value is asked. So transform this. This is the peak, right? Phase peak. So from phase peak, how do I go to line RMS? Anyone? I can also write it as 3√3. Vm means √2 times V phase RMS, right? And V phase RMS is √1 by √3 times V line RMS. So by √3 V line RMS, LINE line. So this √3 gets cancelled. It is 3√2 V line to line by pi is VDC. So this is the formula of the linking the AC and DC voltages. This is the AC side voltage, this is the DC side voltage. And for a three-phase, the relation is this for three-phase diode bridge rectifier. If this is controlled, then a cos alpha will come. Okay, I told you in the previous weeks. So 3 root 2 by V line to line. So what is 3 root 2 by pi? Anyone? Sorry, 3 root 2 by pi, what is it? $1.35, right? So 90 is equal to, by 90, 180 by 2. Because this is the DC link voltage, half of that. Two devices are there, right? So VDC by 2. So 90 is 1.35 times V line to line. So what is your V line to line RMS? Tell me. Yes, I want an answer.
66.66.
Correct. So your line to line RMS first part is done. Part A. This is how you link the two sides and then determine any parameter, either the DC or the AC. One is given, one is to be found out. And then the current rating of the diode. So for a 6 pulse, how much duration the diode conducts? Out of 360-degree full cycle, how many times one diode conducts? And for how many degrees?
So 120.
Correct. So one particular diode will be conducting for 120 degrees of a complete cycle, or in other words, only 60 degrees for a half cycle. If you take the positive half cycle, because in three-phase such things don't matter because we are talking about the full cycle. So for 120 degree, in 360 degree, a diode will conduct. This is the conduction period. Okay. So what is the RMS? Root over 120 by 360 times total I. Because diodes will carry the load current, right? For 120 degree, if one diode is conducting 120 by 360 whole root over RMS. So 100 ampere is the DC load constant. You assume load as constant. Okay, DC constant current, 100 ampere. So that is a square wave, and that is borne by one diode for 120 degree. It's carrying that current. So that 100 times that fraction is the RMS. So 1 by root 3 times. Agreed? 1 by root 3 times, right? Sorry, 1 by root 3 times of 100 amps. So what is the I diode RMS? For the complete cycle you determine RMS value. Okay. So 100 by root 3 you do. What is it?
57. 57, sir.
57, right? Around 57.72. This part B answer. Okay. This is a part A answer. This is another. So now take the next problem. Read it. Problem visible on screen, right?
Yes, sir.
Yes, yes. This is a new problem, so you should be able to see the slide. Just read the problem and then let me know. Problem may seem to be difficult, but it is not so. It is easy, right? Direct problem. Still, you read the problem. So it is again a 12 pulse thyristor braced device, and you are given some information that the DC link voltage is total DC link voltage is 2 kilovolts and firing angle 60 degree, because now it is a thyristor based, right, controlled rectifier. So again, I gave you the information, right, already, that V3 root 2 by pi V line to line RMS into cos alpha will come now, because now it is a controlled rectifier, is equal to VDC. But what is VDC for one device? For one device, you apply this transformation formula. So VDC by 2 is 1000 volts, which is equal to 3 root 2 by pi V line to line. You tell me the value of this V line to line. Or these were line to line, all are same, right? Because DC link voltage here and here same, right? 1000 volts each. So line to line will be also same. Cos alpha. Don't forget cos alpha. So calculate V line to line. Tell me the answer. This is 1.35. Okay. You are able to remember it, then all time you don't have to calculate this. So what is V line to line? 100 by 1.35 cos alpha. Calculate V line to line. Alpha is 30 degrees. Oh, sorry, 60 degrees. So what is V line to line? Tell me.
1480.
Okay. Of the star, right?
Yes, sir.
Now, if someone asks you what is the turns ratio, if I give you this line to line voltage to be 415, I'm framing some question, for example, to check whether you are totally understanding it or not. So, can anyone tell me that what is the phase shift between the phase voltage of this coil and the phase voltage of this coil? First, you tell me this, as well as tell me the phase shift of this voltage with this. Voltage across this coil, if I name as V3, voltage across this coil, if I name as V2, and I gave you voltage across this coil as V1. What can you comment about the phase shift of the voltages V1, V2, and V3? It is a one line. If someone understands, then it is a one line answer. What is the phase shift between the voltages, that is the angle between V1, V2, and V3? Is there any phase shift or not? Will there be any phase shift?
V1, V2, sir, 30 degree. V1, V3, no phase shift.
No. You are memorizing. 30 degree, why? Star and delta line voltages are 30 degree apart. But for a transformer, if one coil is primary, one coil is secondary, another coil is tertiary, there would not be any phase shift, because transformers are meant to be magnifying or reducing the voltage amplitude levels, coil to coil, phase to phase. So for transformer, phase to phase transformation happens on magnitude. They are not phase displaced. So the voltage across this coil, if it is for 415 turns, maybe 100 turns, and if I keep it as 200 turns, then it will be 415 into 2 only, but not in no phase shift will be there. Similarly, if this is 100 turns and this is 200 turns, 415 again will be there times 2. So why are you telling phase shift? Coil to coil transformation happens in a transformer. So coil to coil voltages will not be phase shifted. But why the phase shift is coming? Because this voltage V1 and V2 are not phase displaced. Similarly, V1 and V3 are also not phase displaced. So the line voltage of this side, this one, if this is 0 degree, what is this? Line voltage. Angle. If I assume this as 0 degree at the line, what is this voltage angle? Tell me. Tell me. Coil to coil transformation happening, right? No phase shift. So this is also 0 degree. But what is the line? Line voltage? Same, because delta, phase and line are same. But what in star? Star coil, this voltage is 0 degree, because this is 0 degree. But what is phase? This is 30 degree. Because in star, once you take line to line, the phase to phase voltage gets transformed by 30 degrees. So star line to line voltage and phase to phase voltage are not same. Why? Because this is A, this is B, this is C. Now what is VAB? VA minus VB plus VB. So this is VA. So this is VAB. This is 30 degree. If you compute, this is 120, you assume. You see this is 30 degree. So that's why a 30 degree line phase shift came. Not due to the transformers in this case. Because transformer phase to phase don't give any phase shift. It is only the game of the line voltage that introduces the phase shift. This point is clear or not? If someone asks you any time, coil to coil, no phase shift will happen. But you see, the coil is there, but the line is here, right? Line to line, there may be some phase shift. That the transformer doesn't care. Transformer coil to coil, no phase shift will happen. This point is clear or not? Tell me, or else I will repeat. Any doubt? Remember, phase to phase transformation by transformer introduce no phase shift. But line voltages may be shifted. I will mark it in some other color. Line voltage may be shifted, right? But phase-to-phase transformation voltages by transformer introduce no phase shift. So this is another point, right? So no phase shift, I will just highlight. No phase shift in phase to phase voltage. Phase or coil voltages, I can write. Coil is one phase only, right? In coil voltages. So phase shift, where it arises from? It arises from the line arrangement, right? That is a.
So here secondary delta connection will have no shift in line and phase as well.
Correct. Because in delta, what is it? In delta, line and
phase voltages are same.
Yes, yes. So then it cannot happen. For a transformer, it is not possible to provide any phase shift.
Correct. Okay.
These two I am not talking about. One of this and one will have 30 degree. Then only the currents will be displaced, and if you add, then harmonic cancellation will happen, right? So now any doubts? We are at the very end of the session and this is the final session. Any doubt if you have, you can just ask. We can take another 10 minutes and discuss anything. Any one of you, if you find some doubts, you have the group also, but still you can pose any doubts. Any concepts of the 12 weeks you want me to repeat, or any additional material you require, you can just request for it. We can provide some more clarity about any concepts, any suggestion that I may have left over something that you find difficult to understand. You can just tell me. Any question? Because after this, there will be no session, right? This is the final session. Anything that I have not covered, you have some suggestions or something, feel free to ask, okay?
in UAPC problems.
UPQC.
That means it's a 10th
Yes.
week. 10th week we have solved the problem for finding the source current. We have to use the fundamental frequency, sir.
Yes, your voice is
Fundamental
breaking.
voltage.
Can you please repeat your question? Your voice was breaking from the beginning.
At week 10, sir. At week 10, the problem under UAPC, ATF, UAPC ATF,
Yes.
you have calculated the source current. For the source current, you have to use the formula power into cos phi divided by voltage. Under this voltage, we have to choose the voltage as a fundamental voltage, VS1.
Because for see why the power transfer happens. I told you power transfer happens because of the fundamental of the voltage and current only. So whenever you are talking about computation of some powers, always remember whenever you are calculating some powers, PQS, anything, take fundamental. Okay. Always, because power transfer happens only for the fundamental component of what? Voltage and current.
Correct.
And the phase shift between those two fundamentals, the angle between them, once you know, that will tell you the information about P, cos of that angle. The sine of that angle will give you information of Q, and the total will give you S. So why, once you know that information from the fundamental, it becomes easy to compute, to do power analysis. And from power balance, we can find the fundamental components. Then how can you find out the harmonic analysis parameters, the details about the harmonics? From the nature of the waveform. Because we already learned how to deal with some waveforms, the quasi waveforms or the square waveforms. All those we have seen how to tackle them. So once you know the fundamental value of one waveform, whose shape you already know, then it is easy for you to determine the harmonic strengths of some other order harmonics. Because waveform you know, maybe it's square, maybe quasi square, all we know how to tackle. And their individual strengths you know, because you know the waveform. And also you know the fundamental value, maybe it be peak or be RMS. So from that information, just like the problem we solved in the previous previous day only, same from fundamental information you saw how we calculated the nth PWM voltage harmonics or the current harmonics. Agreed on. So harmonic analysis or harmonic strength from waveform information, and the power information always from the fundamental. So that is why we use the power balance. That is the main reason we use power balance to determine fundamental component parameters. Maybe you have seen in some week 2 or 3 in the early weeks, we used to do power balance. Why you used to do power balance? Such that we find the strength of the fundamental component. Because you remember power transfer, then write it down. Power transfer happens only for fundamental of voltage and current. Because power is always required in that form, power frequency form. You don't want power in some other forms, right? And power transfer cannot happen for fundamental of voltage and third of current. Why? Anyone remembers why? V3 and I1 P equal to, if you integrate and solve over a time period, it will be 0, right? Product of two sine terms or cos terms integrated over a time period will be 0. Because there are other frequencies, right? To integrate two sine products of different frequencies, they will form some cos and sine terms, integrate and get 0 over a cycle. But if those two sinusoidal parameters are having same omega, may it be having some phase shift, no problem. For phase shift, no problem because they will give you a cos at the end. You have seen in the derivation, but they needs to be of the same frequency. If they are of the same frequency, you product them and integrate, you will not get 0. You get something RMS into something RMS and multiplied with a cos of the angle between the two. For P, I am telling. For Q, again, you know, you will get a sign. And if you just check the RMS values, you get the S. So that is the thing, that power transfer is only happening due to the fundamental component. No other component unhomogeneous. To take the homogeneous components, V3, I3 not desirable because either your voltage is sinusoidal and the currents are distorted. No question of V3 there. But V3, I1 or V1, I3, no power transfer. Power will not be there. So average power will not exist for that. Instantaneous power does not, when you average it, it will be 0. So we mean the average power. Power is always average, right? When you average, it will get 0. So that's why power, always you take fundamental components. This is very important and useful in most of the problems to determine the fundamental component. Somewhere or the other, you need to apply power balance. Either you have to memorize 100 of formulas, or if you don't want to memorize 100 of formulas and want to take this approach, then you are saving your memory to just, you can apply power balance and get the formula. And by doing, sometimes you can just, it will come naturally. You don't need to memorize anything. Okay. That is, power balance is very helpful for fundamental analysis. Most of the problem, fundamental component, when they ask you to determine, you just do power balance. Power balance, once you do, you can find out that. But while doing the power balance, can anyone tell me what is the current that we take? We write now that √3 times V into I into cos phi equal to some power, active power. And then we determine V1, I1 RMS. V1 RMS, I1 RMS. Can anyone tell me what is this V and I? Fundamental line RMS or phase RMS? Line or phase parameters? Anyone can tell?
Line.
Correct. Please don't forget it. Okay. Don't take it as phase. Because if someone then asks you to compute some impedance values and you take this I and divide with V and tell them the impedance is this much, you will be wrong. Because if you take line current, you cannot calculate impedance. For calculating impedance, effective impedance or Thevenin impedance, you need to calculate V phase, I phase, and then divide the two. Because for 3-phase circuits, you take per phase analysis. This analysis is very important for parameter determination. 3-phase parameter determination. Circuit parameter, okay, network parameter determination. Because there, you need to draw the single phase equivalent and per phase analysis we do. For example, in per unit, some impedance is given and you are doing with line. Not work. It will not work. You have to go for phase approach. But this approach gives you the line. So you don't blindly apply. You just apply. This is line. Okay, line parameter. You are doing overall 3-phase power balance in a balance. May it be balanced or may it be not balanced. Can you tell me this scenario is balanced scenario or unbalanced scenario? Balanced, right? What will you do for unbalanced? Can you apply net 3-phase power balance, or you will do phase-to-phase analysis? Per phase, you see what power is there and what power is generated. That way you will do only, na? In case of unbalance. 1-to-1 you will do. One phase to one phase. You will just do the power balance, right? That is the way. So there, all your parameters will be in phase. But if you apply this formula, which takes into account the total 3-phase circuit power for a balanced scenario, this is for balanced scenario, then you will get the line quantity. And from there, if you want to find some network parameters, you have to go for phase approach. Okay, phase to phase or one phase approach. Okay, single phase equivalent approach, where you break the 3-phase network, balanced network, into one phase network, single phase network, and you analyze for that, determine the parameters. Because for the other two, in a balanced scenario, that will be same, right? So those are some implications that you have to follow to determine some parameters when they are asked to be determined, right? So any more doubt? These are some very basic fundamental tools that I gave you, and I followed these tools only during the whole session. No other formulas or very complex things I gave you. All the things are very logical, and by power balance and all those tools, very basic tools, fundamental analysis, we determined everything. They will all fall in place like that. So yes, more doubts? Just ask. Any doubt you have out of the 12 weeks? Because we'll not meet after this. We can connect over the WhatsApp group, but you can ask me directly here only. So when is the exam?
27th Saturday, sir.
Okay, I hope your preparation is going well, but you need to brush up more on the fundamentals, right? Because most of the questions will be very easy, but fundamentally very tricky. One line. Not complex questions will be there. Very complex questions will not be there, right? So if you follow thoroughly, I don't think there will be a problem. Yes, someone is asking something, please.
So, since I'm not from electrical background, where can I brush my fundamentals from? Which book to refer?
What domain you want to, because electrical is vast. So in which domain you want to brush up?
Just for this subject, because I have just taken this subject as from electrical department.
Okay, so you are in EC, right? EC background.
Yes, yes.
Electronics
yes,
background.
yes.
So
Sir.
for that, because in electronics background, you must be dealing with network theory, right? In
Yes.
network theory, if you follow Alexander Sadiku's book, then your concept,
Yes.
I think, is very clear. Because what we are doing here, we are doing nothing here but harmonic analysis and power balance and power analysis, determining power. So all those are circuit theory, basic circuit theory. Okay. So you can follow
Yes,
Alexander Sadiku's book. For your brushing up your this simple power triangle rule, how to arrive at, because we are taking some power systems approach which you may not be aware of. So basic electrical circuit theory books will help. How to analyze three-phase circuits, three-phase transformers you can also see, three-phase circuits, AC circuits, how they are analyzed, what is the power balance equation, how they are derived, or they are doing average power. So their book is good, okay? That book you can follow, Alexander Sadik.
Okay. Sir, can we have some previous year question papers to refer to?
Previous year question papers, I have already drafted you all the slides. They are only the previous year questions only, right?
Okay.
All
Okay,
questions I have covered. None of them I have left. There is not a single question that I have left. Okay. All I have covered. Partly in the assignments, which you have already the solution with, and all the other questions I have taken up in this session. Okay. All the concept, whatever type of problem that could have been formulated has been covered, right?
Okay.
So, one doubt, sir. What is the weightage of these assignments and the final exam for getting the final certification?
I think 30-70, something like that used to be there. You can see the course first page. 30-70,
Okay.
I hope.
Okay.
Maybe I am missing something. 30-70 or 40-60. Just check.
Okay, sir.
That is in the very first page. In the introduction page, it is there. Okay.
Mm-hmm. Okay.
And there is some rule, I think, that for getting the certificate, you need to score 40% in the final exam. So don't think that overall, if you have good in the assignments and you don't get good marks in the final exam, or pass marks, what we tell as the 40% marks in the final exam, you will not get the certificate. Or for the domain certification, if you apply, the domain certifications are also there, like in the NPTEL Power Engineering Domain Certification. If you want to become the domain scholar, then also you have to pass this exam with some, for which the criteria is 40% in the final exam. whatever be the weightage and weighted calculation of your overall marks, that is there to get the certificate. I think that is 60%, but or 40%, I am not remembering. But one thing that I want to tell, in the final exam, you should have 40%. Okay, should score 40%. If the marks of the final exam is 100, you should be scoring above 40 to be declared as pass. Okay.
Okay, sir. And when will the hall tickets be issued, sir?
Yes, yes. Can you repeat, please?
When will the hall tickets be issued? Because I see it is still not issued.
Yeah, they are issued only 1 week before. Hall
Only
tickets
1
are
week before.
Yes,
The problem
only 1
is
week
we
before.
have elections on the same date.
Yes, yes.
So, I mean, the previous day. The previous day. So,
once mail to the support@nptel.iitm. I think that mail ID is there. Just
yeah.
tell them this, and they will generate for you. They will at least generate for some cases.
Yeah, so that we can plan our travel accordingly.
Yes, yes. Yeah, you can just mail them stating this, and they will issue.
Okay, sir. Thank you.
So any doubts you have from the course, you can just connect over the group, and we can take. Okay.
So exam will have theoretical and numerical questions both, or mostly numerical?
Both. See, mostly you are solving numericals only, but some analytical questions will be there. But mostly numerical. Okay. And if you have solved all the questions which have been covered till date and solved the assignments properly, I don't think it will be a difficult exam for you. Okay.
Okay.
It will be very easy if you solve all the questions and then go.
Okay, sir.
Thank you. You can just connect over if you have some doubts in WhatsApp. The group has been there.
Yes.
Or you can just ask. Thank you.
Okay.
We can end the session, right?
Thank you so much, sir. Thank you for your patience and great understanding, bearing with us. Thank you so much.
Thank you.
Thank you.
Thank you, sir.
Thank you very much.